Alrighty, looks like we're back in the lab yet again with a new set, but I think this was from last episode if I remember correctly, and these fruits were from last episode's Get Juice too. Now pepper too, interesting. Okay. So today's lesson, walking water. This is gonna be a science experiment. So this setup looks very, maybe it might look complicated actually, I'm not sure. But what it teaches is actually really huge. I've got 12 cups here, and every other cup is going to get a combination of colored water or the colored drinks that I've got. I try to get like some food coloring-ish kind of things. So the empty cups are going to become new colors as the water walks toward them. We're going to have red, purple, green, as well as blue. So what we're going to do now is fold the paper towel strips into thick strips, like tiny bridges. And we're gonna go ahead and place these in between the cups. So as you can see, like in every other cup, I'll go ahead and place the food coloring in so we can see the differences in cups. Tries to make a pattern as well. So watch this. The paper towel starts absorbing the water immediately as soon as you put it in contact with it. And that's because of a concept called adhesion. Water molecules wanting to cling to the fibers. And really, that's kind of the definition, I guess. That is cohesion. Another way of thinking about cohesion is water sticking to itself, pulling more water behind it. And we called that kind of teamwork capillary action. And the wild thing is, just like last episode, this is actually happening inside of you as well. You know, this is a new concept in nature. Trees taller than buildings, like the ones in the Redwood Mountains, I believe, or the Redwood Forest in Joshua Tree, pull water from deep into the soil all the way up to the top of the leaves. And if you look at those trees, you know that's a very, very far distance to go. Flowers use it to stay alive. I also want you to think about it fighting the force of gravity as well. So even your body uses it. Your tear ducts, your saliva glands, your sweat pores, they all depend on movement through tiny, teeny tiny spaces. Every time water walks across this paper, you are seeing the same exact physics that keeps entire ecosystems of forest alive. And I guess this might be kind of cool to you. I think this was kind of cool as well. Capillary action helped early scientists understand how blood vessels work, because your capillaries, which are the tiniest blood vessels in your body, I'm not sure if we can even see those like on the outside of our like physical body or our skin, use the same physics to transport nutrients and oxygen. This experiment isn't just cute. In the end, it's a model of life. Until next time, my future scientists, Until next time, my future scientists, explorers, innovators, and inventors.